In this Explain Everything, I want to examine the pathology, the endocrine pathology of hyposecretion or hypersecretion of cortisol. So we can again either have hypersecretion, in which case cortisol levels are going to be increased, or hyposecretion, in which the cortisol levels will be decreased. And noting that this could either be due to a primary pathology resulting from a problem in the adrenal cortex, or it could be secondary due to a problem in the anterior pituitary, or it could also be considered secondary if it is due to a problem in the hypothalamus. So let's just quickly review the hormones that are secreted from these glands. Okay, first of all, the hypothalamus is going to be releasing CRH. Anterior pituitary is releasing ACTH, and then the adrenal cortex itself is releasing cortisol. Important in the further discussion of this is the negative feedback. Cortisol is going to inhibit the release of ACTH from the anterior pituitary, and also the release of CRH from the hypothalamus. So in the coming slides, we will look at the importance of these negative feedback loops in the primary and secondary pathologies. Let's first look at secondary hypersecretion due to a problem in the hypothalamus. So what is happening here is that we have a problem that is increasing the secretion of CRH from the hypothalamus. This is then going to overstimulate, acting as a tropic hormone, overstimulate the release of ACTH from the anterior pituitary, which is then going to overstimulate the release of cortisol. Now we have to take a look at the negative feedback loops and see how these are being affected. Increased levels of cortisol would normally go back and inhibit the release of CRH from the hypothalamus. However, because this is where the actual problem lies, okay, this negative feedback is no longer going to be effective. It would also inhibit ACTH from the anterior pituitary. But because it's being overstimulated by the CRH coming in, that will override this inhibition, and negative feedback will not be effective at this level. So the net result is going to be that we have an increase in CRH, we have an increase in ACTH, and we have an increase in cortisol. Now let's look at secondary hypersecretion due to a problem at the anterior pituitary. So what's going to happen now is that the anterior pituitary is going to hypersecrete the ACTH. There is a problem there, which will then increase levels of cortisol. Looking at the negative feedback loops. Cortisol, these increased levels of cortisol, are now going to go back and inhibit the release of CRH from the hypothalamus. There is no problem with the hypothalamus, so in effect this is going to result in a decrease in levels of CRH. These decreased levels, however, are not going to affect the release of ACTH from the anterior pituitary, because this is the site of the problem, so it is going to continue to overproduce this ACTH. Negative feedback, okay, is also not going to be effective here. Okay, this negative feedback will no longer be effective because the site of the problem is the anterior pituitary. So if we look at this now, what we're going to see is that CRH levels will decrease due to that negative inhibition. ACTH levels are going to increase due to the pathology of the anterior pituitary, and cortisol levels will increase due to the increase in the tropic hormone stimulating it. Next is primary hypersecretion due to a pathology at the level of the adrenal cortex. So the adrenal cortex is hypersecreting cortisol, therefore cortisol levels will increase. Now looking at the feedback mechanisms, due to this increase in cortisol, okay, the negative feedback will be going back to both levels, to the anterior pituitary and the hypothalamus, and because there is no pathology at either level, both of these will be inhibited by negative feedback. So if we look now, CRH levels are going to decrease due to that negative feedback. ACTH levels are going to decrease due to that negative feedback. So overall, both of the tropic hormone levels decrease, whereas again, due to the hypersecretion, cortisol levels will increase. Now let's look at hyposecretion. Secondary hyposecretion due to a problem in the hypothalamus. there is going to be a decrease in the level of CRH. Therefore, there will be a decrease in ACTH and a decrease in cortisol levels. Okay, so looking overall, if there is secondary hyposecretion at the level of the hypothalamus, all three hormone levels will decrease. Secondary hyposecretion at the level of the anterior pituitary is going to decrease levels of ACTH and therefore decrease levels of cortisol. Now we have to look at the effect of this decrease in cortisol levels on negative feedback. Because there's less cortisol, there is going to be less negative feedback at the level of the hypothalamus. So if we have decreased the level of negative feedback, in essence, what we're going to do is increase the levels of the releasing hormone. So secondary hyposecretion at the level of the anterior pituitary, you're going to see an increase in CRH, a decrease in ACTH, and a decrease in cortisol. Finally, let's take a look at primary hyposecretion. This is going to be at the level of the adrenal cortex, and we now know that we are going to have a decrease in the level of cortisol. Okay, once again, looking at the negative feedback, because of this decrease in cortisol, again, there will be less negative feedback going back to the anterior pituitary, less negative feedback going down to the level, or going up to the level of CRH. Therefore, you should see an increase in CRH and an increase in ACTH due to the decreased negative feedback because of those low levels of cortisol. So overall, you are now going to see an increase in CRH, an increase in ACTH, and a decrease in cortisol. In summary, for hypersecretion, anything at or below, at or below the level of the problem, the levels will increase because it is hypersecretion. Anything above the problem will decrease. So just quickly taking a look at that, anything at or below will increase. So if the problem is at the anterior pituitary, at that level that will increase, and below that will increase, above will decrease. For hyposecretion, anything at or below the site of the problem will decrease, hyposecretion, and anything above the level will increase. So again, for example, if the problem is at the anterior pituitary, at or below will decrease, anything above will increase. I will summarize this in the chart on the next slide. Okay, so just remember that the direction of the arrow is going to match the pathology. So if it is a hypersecretion at or below, hyper will be increase. Okay? If it is hypo, at or below will be a decrease. And then you just have to go the other way. Above is going to be the opposite, so hyper will be a decrease and hypo will be an increase. So this is a relatively quick and easy way to remember how to determine the levels of these hormones for hyper and hypo secretion.